Welcome. Let's understand DC power cable sizing and voltage drop calculation. Let's start with a discussion about the 125 volt DC power cable sizing. These are design inputs. Nominal DC system voltage, 125 volt. Allowable maximum voltage based on 1.75 volt end cell volt, 101.5 volt. Allowable maximum voltage based on 2.35 volt maximum equalizing volt per cell, 136.3 volt. Ambient temperature equals 40 degrees, inside room, and 50 degrees, outside room. Continuous load, 12 hours 300 ampere. Momentary tripping, 1 minute 280 ampere. Emergency lighting loads, 3 hours 40 ampere. Momentary restoration, 1 minute 70 ampere. Battery charger rating, 800 ampere. Cable route length, 25 meters. Cable maximum operating temperature, 90 degrees. Ampacity, current carrying capacity, sizing, is required to ensure minimum size of conductor, which will cater load requirements in extreme condition. Voltage drop calculation, is required to ensure voltage at load end, shall be within defined operating range. Allowable voltage drops, 5% of system nominal voltage throughout, from the supply end to the load end. Voltage drops shall be limited as per client specifications requirements, some requirements values is shown here. It should be noted that DC voltage drop shall be calculated at allowable maximum voltage based on 1.75 V end cell volt, 101.5 V. Cable DC resistance at maximum operating temperature has to be taken into consideration for calculating voltage drop. Ampacity, current carrying capacity, sizing. Total current equals continuous plus momentary, and safety margin. Let's size cable from battery to DC dB as per design input. Total current equals 300 plus 280, and with safety margin of 25%, equals 725 ampere. Ampacity correction factor. Group rating factor, K1, equals 0.7. Rating factor for variation in temp, K2, equals 1. Total correction factor equals K1 K2 equals 0.7. Group rating factor, K1. Refer manufacturer catalogs and consider factor based on cable laying methods like cable laid in ground or in air, single layer touching, single layer with spacing, double layer touching, etc. Rating factor for variation in temperature, K2. Refer manufacturer catalogs and consider factor based on design ambient temperature. So, ampacity for which cable will be sized equals total load current divided by total correction factor equals 725 divided by 0.7 equals 1035.7 ampere. Now, refer manufacturer cable catalogs, and consider size of cable, which shall meet above calculated current rating, and laying methods. Considered cable with 2 run, 1 core, 500 square mm copper cable, 2 run with 1009 ampere per core. Ampacity of selected cable is more than required load current, hence selected cable is adequate to carry the required load current. Refer client specification, and consider applicable cable like PVC or XLPE insulated, 1 core or 3 core, current as per laying method from manufacturer catalog. Let's start with a discussion about the DC cable voltage drop calculation. As shown here, voltage drop depends on load current, route length, cable DC resistance, number of cable run. Calculated value of voltage, based on design input is 0.66. Now let's calculate voltage regulation, equals voltage drop divided by minimum DC system voltage, which gives the value 0.65%. Since the voltage regulation is within the limit of 0.8%, the selected cable size of 2-run, single core, 500 square mm, copper cable per phase is justified. Optimization check. To meet current requirement, consider higher cross-section of conductor, with single run, or consider lower cross-section, but with multiple run. It may possible that you can meet current rating requirements with single run but not voltage drop. So, choose cable size and number of run optimally. Thank you for your attention and time. More stuff coming soon. Don't forget to subscribe.